Yeah, it's some kind of guy. In this video, we're still continuing with antimalarials, and we are going to talk about the first antimalarials, the quinine, quinidine, and quinacrine. We're going to talk about their source, mechanism of action, the specific indication, problems, metabolism, and SAR. Please don't forget to subscribe, like the videos, and share. Let's go. Yes, let's have their structures. For quinine, this is the structure. You have a methoxy here. Here there is hydroxyl group. Here there is OH. There is hydrogen. Here we have hydrogen. So this is quinine. For quinidine, the changes they are here. This is SR. This is RS. But for quinidine is SR. That's the only changes as we saw the previous video. Now for quinacrine, this is the structure. Here there is a methoxy group, but here you have chlorine. Then here, instead of this carbon, there is amino group. Then there is a methyl group here. That is quinacrine. I think here, let's do this. Make this one R1, this one R2. So mean that if it is at R1 for quinine, at R1 we have OH, then at R2 we have hydrogen for quinine. Then for quinidine, it's the opposite. R1 is hydrogen, then R2 is OH group here. Then here they will have hydrogen, but one is at alpha position, the other one is at beta position. So for quinidine it will be SR. It will be here S, here R. But for quinine it is RS. Okay, now the source, these two alkaloids, they are from cinchona tree or cinchona bark, the bark of this cinchona. It was known as quinquina. Then for quinacrine, this one is synthetic. It is synthetic. And a 9 amino acridine. It's the ring, this ring. At position 9 there is amino group. For the mechanism of action, First, when you look at these drugs, we have this N, this nitrogen is tertiary. We are going to see in SAR. Even this one is tertiary. I see. So, mean that here the pH is basic. It is basic. It's around 8 point. It's around 10.2, around there. Then also we have this nitrogen here. The pH is around 8.4, approximately around 8.4. So we have those basic groups. So for the mechanism of action, the parasite normally feeds on hemoglobin when it enters the red blood cell. So when it enters the red blood cells, it feeds on hemoglobin. So to break this hemoglobin into different components, now it will produce the free heme. Free heme is also known as the hematine. And this hematine is very toxic. It's very toxic. So it has to convert it into non-toxic form. To convert it into non-toxic form, that is hemozoin. And to do this by reduction. So this hemozoin is the biocrystallized form. Biocrystallized form. They used to say it is the polymerized, but previous researchers, they said that it is biocrystallized form and it is non-toxic. So the parasite uses this hemozoin to make nucleotides. Now, these drugs, they are basic. And this one occurs in this one. They all occur in the food vacuole. In the food vacuole. This metabolism of the hemoglobin into the heme and hemozoin. Now, for the drugs, they are basic. And these drugs, they will enter the food vacuole through the channels, through the positively charged channels. When they reach inside the cell, the food vacuole, inside it is acidic. The vacuole is acidic inside, around the pH of 4, around 4. So, meaning that this drug will ionize. The drug will ionize to take the positively charged protons. So, if this is a drug, so outside it will be charged with protons. And this drug will be trapped. It is trapped inside the food vacuole. And remember also the channels, they are positively charged. So this drug will remain in the food vacuole. And this drug will bind to the hematine. this free heme, preventing its conversion into the hemozone. So mean that this toxic metabolite will remain in the cell. So mean that we shall have damage to the parasite. The parasite will be destroyed. Damage or destruction to be destroyed by this toxic hematine or free heme. And also, the red blood cells, after being detected that they are infected and this toxic substance, they are detected by the cyclin and they are also destroyed. That's how these drugs work. So that's the mechanism of action. And this mechanism of action is for all the 4 substituted quinolines. The chloroquine, amodiaquine, and other 4 substituted quinolines. And we shall talk about them also. Now, for specific indication, quinine majorly is used as antimalarial. But for quinidine, majorly is used as anti-arrhythmic. So it is used in arrhythmia. In arrhythmias, mainly quinidine. Now, this one, quinine, is still used in chloroquine resistant Plasmodium falciparum malaria. This quinine mainly. And for Quinacrine, this one, after identifying that this drug had low antimalarial activity, they synthesized the other antimalarials like chloroquine, as we saw the previous video, that from here we can get chloroquine. And this one mainly is used in combination with drugs like doxycycline, clindamycin, mefloquine, among other drugs, mainly used in combination. Now, let's talk about the problems of these drugs. Yes, let me get the guy. For the problems, quinine and quinidine, these drugs at overdose, they can lead to toxicity. And this toxicity is known as synchronism, or the synchronism. This one is characterized by tinnitus, headache, disturbed vision, nausea, so the drug has to be withdrawn. If this one occurs, the drug has to be stopped. If not, this one can continue to damage the GIT, the CNS, the cardiovascular system, and also the skin. GIT may have diarrhea. CNS may have ataxia, convulsions, and can lead to coma. Then for the severes, here we have arrhythmias. And also for skin crashing. So that's for quinine and also quinidine. They lead to chinchonism, as you can see from chinchona. Now, when we talk about the metabolism, mainly we are going to talk about for this drug here, the quinine. This drug can be metabolized by CYP450 enzymes, but mainly the CYP3A4. This enzyme leads to hydroxylation of this drug. This is position 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, this is 9. This is 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime, 7 prime, and 8 prime. So this drug leads to hydroxylation at this position 2, form OH group. Even here can lead to also hydroxylation at position 2 prime here, form OH group. So this is the major metabolite. It is 2 prime dihydroxy derivative or metabolite or dihydroxy quinine. So this metabolite is the major metabolite after the quinine metabolism. And we saw that drug like mefloquine, they substituted this position to overcome this problem, as we are going to see. So generally, that's the metabolism. For the SAR, we are going to begin with this position here, position 1. We say that this nitrogen, the N1, is responsible for the ion trapping inside the food vacuum, such that the drug remains in the food vacuum and binds to the hematine, preventing its conversion to hemazone. And it should be tertiary. And of course, if it is tertiary, it should be basic. This one. Then here we say there is OH. Substitution of the OH group. This one, or esterification can lead to diminishes activity. So it is very essential. This. Then you have the quinoline ring. Quinoline ring, it is very essential for activity. It is essential for activity. It is responsible for binding to hematine by stacking. By stacking binds to the hematine. Then this one, the methoxyl group, increases the lipophilicity. It is responsible for the lipophilicity of the drug. Then we have this group here, aryl group. The aryl group, it can be saturated And saturation is to decrease the toxicity and increase in potency of the drug, but it's relatively expensive to produce that one. So it is expensive, but can reduce toxicity and increases the potency of the drug. What else? We talk about the stereochemistry. For stereochemistry, the position 9 and position 8. This is position 9, this is position 8. So it should be R, S, or S, R for activity, but shouldn't be R, R, or S, S. This one diminishes the activity. And other stereochemistry, here we have S, R. I mean, we have position 4 here, we have S and R, position 3. So these ones, they increase or they lead to fitting in the binding site. Fitting into binding site. So at position 8, 9, we must have this either RS or SR, then plus position 4 and 3 as SR for binding, such that it can fit into the pockets. So generally, that's the SAR for the quinine and quinidine. We are not going much through this because it is not much used. And for quinidine, mainly it is used in arrhythmia, so mostly we are on quinine. Yes, for this video, let's stop here and wait for other videos. Please don't forget to subscribe, like the videos, and share. Yes, it's MK the guy. Thanks so much.